How do we round a decimal to a given number of decimal places? In this video, we're going to demonstrate the steps and work through some examples. If you find this video helpful, please consider leaving a like, a comment, sharing this video, and subscribing to our channel for more content like this. Rounding a decimal is the process of simplifying a number to make it easier to work with, while keeping its value as close to the original as possible. We need to find the closest neighbor to the number that we're rounding, according to a given number of decimal places. This question asks us to round the decimal 4.234 to 2 decimal places. To round a decimal number to a given number of decimal places, we first need to understand that every digit after the decimal point has a unique position. The first decimal place is the first digit after the decimal point. The second decimal place is the second digit after the decimal point. Applying that principle to this question, 2 is the first digit after the decimal point and the first decimal place. 3 is the second digit after the decimal point and the second decimal place. And 4 is the third digit after the decimal point and the third decimal place. Correctly identifying the digits in the decimal is a crucial step in being able to accurately round a decimal. While the second digit, 3, is where our number will end, the third digit, which is 4, is the decision maker that tells us which way to round. The question tells us to round 4.234 to 2 decimal places. That means we need to keep every digit up to and including the second digit after the decimal point, which is the 3 digit, and remove any digits after that. But we still have one more step to complete before we've correctly rounded this decimal. We've been asked to round this decimal to 2 decimal places. That means we need to keep everything up to and including the second digit after the decimal point, and remove all of the other digits after that. However, the third digit is important in deciding whether we need to round the second digit up or down. If the third digit is 5 or above, we need to round the second digit up by 1. And if it's below 5, the second digit stays the same. In this case, the third digit is a 4, which is below 5, so the second digit stays the same, giving us the rounded decimal 4.23. After rounding a decimal, it's important to indicate that this value is an approximation and has been rounded. We can do that by writing 2dp in parentheses, where dp is a recognized abbreviation for decimal place. So 4.234 rounded to 2 decimal places is 4.23 to 2 dp. Here are some more examples. This time there are 4 digits after the decimal point, and we need to round this decimal to 1 decimal place. To begin, we need to identify the digits by their position after the decimal point. The first digit is 8. The second digit is 1. The third digit is 6. And the fourth digit is 2. Rounding this decimal to one decimal place means keeping everything up to and including the first digit after the decimal point. The first digit is the 8 digit, so we're removing any digits after that. But remember, we need to check whether the second digit is 5 or above, or less than 5. In this case, the second digit is 1, so the 8 stays the same. So 0.8162 rounded to one decimal place is 0.8. Rounding this number to one decimal place, we're asking whether the number is closer to 0.8 or 0.9. The exact halfway point between them is 0.85. Because 0.8162 is less than 0.85, it sits closer to 0.8 on a number line. This time, both digits after the decimal point are 5 or above. To begin, we need to identify the digits by their position after the decimal point. The first digit is 7, and the second digit is 5. Rounding this decimal to one decimal place means keeping everything up to and including the first digit after the decimal point. In this case, the first digit is the 7 digit, and we're removing any digits after that. But remember, we need to check whether the second digit is 5 or above, or less than 5. In this case, the second digit is a 5, because 15.75 is exactly halfway between 15.7 and 15.8. And mathematical convention tells us to round up. So the 7 increases by 1 to become an 8. So 15.75 rounded to one decimal place is 15.8. Even though a number ending in 5 is exactly halfway between the number above and below, it is standard mathematical practice to always round up. This question asks us to round 0.04982 to 3 decimal places. The important digits for the purposes of answering this question are the second digit, which is 4, the third digit, which is 9, and the fourth digit, which is 8. To round to 3 decimal places, we need to keep everything up to and including the third decimal place, which is 9. But the fourth digit is an 8, which is above 5. So we need to increase 9 by 1. The only way we can increase 9 by 1 is to change the 9 to a 0 and increase the digit before it, which is a 4, by 1. So the 4 becomes 5 and the 9 becomes 0, giving us the rounded decimal 0.050 to 3 decimal places. Be careful with the final 0. Even though 0.050 and 0.05 have the same numerical value, we must keep the final 0. The question specifically asked for 3 decimal places, and our final answer must show exactly 3 digits after the decimal point. This question asks us to round 125.384729 to 4 decimal places. The important digits for the purposes of answering this question are the 4th digit, which is 7, and the 5th digit, which is 2. To round to 4 decimal places, we need to keep everything up to and including the 4th decimal place, which is 7. And the 5th digit is a 2, which is below 5. So the 7 stays the same, giving us the rounded decimal 125.3847 to 4 decimal places. Don't get distracted by the long tail of numbers. When rounding this decimal to 4 decimal places, we can completely ignore the 9 at the end. This level of precision is incredibly small. Measuring to 4 decimal places is like measuring the width of a bacteria. This question asks us to round 3.14159 to 2 decimal places. The important digits for the purposes of answering this question are the 2nd digit, which is 4, and the 3rd digit, which is 1. To round to 2 decimal places, we need to keep everything up to and including the 2nd decimal place, which is 4, and the 3rd digit is a 1, which is below 5. So the 4 stays the same, giving us the rounded decimal 3.14 to 2 decimal places. This is the most famous approximation in history. 3.14159 is the beginning of the mathematical constant pi, used to calculate everything to do with circles. 3.14 is the exact number celebrated around the world every year on Pi Day, March the 14th. The final 2 questions are a challenge. First, we've been asked to round 0.9962 to 2 decimal places. The important digits for the purposes of answering this question are the 1st digit, which is 9, the 2nd digit, which is also 9, and the 3rd digit, which is 6. To round to 2 decimal places, we need to keep everything up to and including the 2nd decimal place, which is 9. But the 3rd digit is a 6, which is above 5. That means we need to round the 2nd digit up by 1. However, we've already seen the effect that rounding up a 9 has. It means that we need to round the digit that comes before it up by 1. And if that digit is also a 9, we need to round the digit that comes before that up by 1 as well. That digit is a 0 and is in front of the decimal point, the whole number part of the decimal. So the 0 in front of the decimal point becomes 1, and both 9 digits become 0, both of which still need to be included in our answer, giving us the rounded decimal 1.00 to 2 decimal places. This double domino effect can be challenging when rounding a decimal like this. When the 6 rounds the 9 up, it triggers a chain reaction that flips the next 9 to a 0 and carries all the way over to increase the whole number to a 1. Finally, we've been asked to round 19.99951 to 3 decimal places, the ultimate boss battle of decimal rounding. This question challenges us with every situation we've met in one single problem. There are 5 digits after the decimal point, and 4 of them are important. The first digit, the second digit, and the third digit are all 9, and the fourth digit is 5. To round to 3 decimal places, we need to keep everything up to and including the third decimal place, which is 9. But the fourth digit is 5. That means we need to round the third digit up by 1. This cascading row of 9s means that to successfully round this decimal, we need to change 5 digits in total, starting with the third digit after the decimal point. That 9 becomes a 0, forcing the digit in front of it to increase by 1. That digit is also 9, and rounding that up forces the digit in front of it to increase by 1 as well. And that digit is also a 9, and rounding that up forces the digit in front of it to also increase by 1. That digit is the first whole number digit in front of the decimal point, which is also a 9. And rounding that up forces the digit in front of it to increase by 1. That digit is a 1, so it becomes 2, giving us the rounded decimal 20.000 to 3 decimal places. This number pulls out every trick in the book. Adding 1 to the third 9 triggers a massive chain reaction that obliterates every single 9 in its path, carrying over the decimal point and turning 19 into 20. Remember, we don't just write 20. To defeat this problem, we must respect the precision requested. Because the question asks for 3 decimal places, we need to keep all of those zeros from the chain reaction. In this video, we've demonstrated how to round a decimal according to a given number of decimal places. With practice, rounding a decimal should become a routine foundation level task. Visit our website at mathsdepot.com for more maths content.